How do you tackle a question like this when you see it? It says, find the hydrogen and hydroxyl ion concentrations in 0.01 molar concentrated sulfuric acid. 0.01 molar is the concentration of this acid. And the question is saying, find the hydrogen ion concentration and find the hydroxyl ion concentration in the same acid. So let's go. So let us assume that 1 mole of the acid is in solution. So we are going to ionize the acid. The acid is H2SO4, aqueous. So when we ionize the acid is dibasic, so, and it's also a strong acid. So it will completely ionize to give hydrogen ion and sulfate ion, or you call it tetraoxosulfate 6 ion. Now to balance the equation, hydrogen is 2 here, you write 2. This is the complete ionization of the acid. So meaning that 1 mole of this acid produced 2 moles of hydrogen ion and 1 mole of this. So this is very, very important to the question. Now, concentration of hydrogen ion. Concentration of hydrogen ion in this acid is 2 times the concentration of 1 mole of the acid, because 1 mole of the acid produces 2 moles of hydrogen ion. Therefore, the concentration of this acid times 2 will give you that of hydrogen, 0.01. So you are going to get 2 times 0.01 means 10 raised to power minus 2 mole per dm cube. So this is the concentration of the hydrogen, 2 times 10 raised to power minus 2. Now, concentration of the hydroxide ion is gotten from this equation. Concentration of hydrogen times concentration of hydroxide ion equals 10 raised to power minus 14. So this is the constant. So this particular constant is called ionic product of water, that is Kw, ionic product of water. So we have found concentration of hydrogen ion, which is 2 times 10 raised to power minus 2. But we have not found concentration of hydroxide ion. The product of the two gives 10 raised to power minus 14. So we make concentration of hydroxide ion the subject, which is this number divided by this number. Let's call this number 1 times 10 raised to power minus 14 is the same thing, divided by this 2 times 10 raised to power minus 2. So we now have 1 over 2, which is 0.5, times, you take only 1/10, raised to power this number minus this number, that is minus 14 minus what? Minus 2. So we have 0.5 times 10 raised to power minus 14. Minus minus is plus. So minus 14 plus 2 will give us 2 minus 14, which is minus 12. So bringing this down to standard form, we shift point to the front and we have 5.0 times 10 raised to power minus 12. Because you shifted to the front to increase the number, you remove 1 from the power. And finally, our answer is 5.0 times 10 raised to power minus 13 mole per dm cube. This is the concentration of hydroxide ion. Therefore, hydrogen ion concentration is 2 times 10 raised to power minus 2 mole per dm cube, or molar. Hydroxide ion concentration is 5 times 10 raised to power minus 13 molar. These are the answers. We can prove that these answers are correct. Recall that Kw is the product of H plus and OH minus, and the product is theoretically and experimentally 10 raised to power minus 14, right? So let's see if we can multiply this answer and this answer to get this. These are the answers. So 2 times 10 raised to power minus 2 times this for OH minus, which is 5 times 10 raised to power minus 13. So let's see what we will get. 2 times 5 is 10. Times, you take 110, raised to power minus 2 plus minus 13. Minus 2 plus minus 13. So we have 10 times 10 raised to power minus 2 plus minus is minus 13. So 10 times 10 raised to power minus 15. To send this to standard form, this is 2 digits number. It has to be 1. So we shift this point here and we have 1.0 times 10 raised to power minus 15. Because you shifted point back to decrease this 10 to 1, we are going to increase the power by 1 by adding 1 to the power. So that is 1.0 is 1 times 10 raised to power. Minus 15 plus 1 is minus 14. Therefore, we have ended up getting this again. 1 times this is the same thing. So we have gotten this again. Because we have gotten this, these answers are correct.